By now we've looked at stoichiometry in class probably a week, and I've used some tools to help guide you through the process to know how many fractions to use. Now remember a couple of things. Anytime that we're dealing with grams, for instance the molar mass, you must use 1 mole as the other conversion, and this is usually like the same substance, so grams of H2O to 1 mole of H2O, but it's always, whenever you have grams in a fraction, it's always 1 mole. And when you have moles to moles, and they're not going to be the same substance, but then you use the mole ratio, and I've seen multiple people having issues with deciding which of those two tools to use. So I have written on the board a couple different times a series of arrows to help you figure out how many fractions to use in your stoichiometry problem. Typically we have some kind of equation. You have A plus B might make AB, and let's just make it more entertaining and we'll put some numbers in here. So in the case of, if we're starting with grams of A, we're going to be able to convert to moles of that same substance A using, and I've done this using the molar mass, because we can convert between grams of one substance to moles of that same substance. When we go on to changing to moles of a different substance, when we do that, we will use the mole ratio. And then our last step typically is going back to grams of the other substance, grams of B. And like the first fraction, we do that using molar mass. So these are, each box here represents a different fraction in the problem, and if you're going from grams of one substance to grams of a second substance, you're going to have 3 fractions in order to solve that problem, and the first fraction is going to use the molar mass, and the second fraction would be mole ratio, and the third fraction would be molar mass. Molar mass meaning that you have some number of grams equaling 1 mole, and then the mole ratio, you would be looking at your balanced chemical equation to determine the numbers involved, so that's where you have numbers other than 1. Now sometimes we can have problems where we won't be working with grams or moles, and so in those cases you enter this road at a different place. You could be given kilograms and asked to convert that to grams, or you could at the end be taking your grams back out, almost doesn't fit on the screen here, back out to kilograms. So let's raise this up a little bit, so there we go. And remember that 1,000 grams equals 1 kilogram. Another thing that you could be asked to do is you could be asked about, you'd be given the number of moles of a substance and asked to find the grams. So if you're starting here at moles of one substance and you're going to grams of the second substance, you're only going through 2 boxes, so that would be just 2 fractions. You can also be given grams to start and end with moles, and that would still be just 2 fractions. So you can start at any point in this series. Another thing is they could give you molecules. And while we haven't used the molecule number in a long time, it is 6.02 times 10 to the 23rd particles, so this would be molecules. We could also be given liters, and that's 22.4 liters equals 1 mole. This also equals 1 mole. And the same could be said here. You could be ending at liters, or you could be ending at molecules. So it depends a lot on what conditions they give you in the problem. If you're given liters and asked to find moles, well then you do this fraction where you convert from liters to moles, and then you do the mole ratio, and then you stop at that point. Depending on what information they give you in the problem and what information they ask you to find is how many fractions your problem could have. It could have multiple steps, or it could just be simple problems of grams to grams, which we see a lot of in the worksheets we've been doing. Now that's not the only part of stoichiometry, this is just the path. We can then be asked other questions like limiting reactant and percent yield, which will be later videos.